To finish today's lesson, if we are able to finish today's lesson early, that's a big if, I'm going to show you what my surgery looks like. So, but we got to see if we can get done with this early, because this comes first. All right, Andre, turn around, face forward. My pen is dying here, so I'm hoping to make it through the period with the pen working. All right, so listen, the first thing we have to do is talk about the quiz. It's actually a very easy quiz. However, if you didn't understand what to do, then it would seem really hard. But once you understand what to do, you're going to go, oh, you know what, that wasn't so bad. So one of the sides is x minus 3, and one of the sides is x plus 8. And it asks you to represent the area. Now, how do you find the area of a rectangle? Everybody? Length times width. So in other words, it's going to be x plus 8 times x minus 3. Now I'm going to double distribute this out, and I'm going to get x squared minus 3x, now I'm going to distribute the 8, plus 8x minus 24. You know, by now I think we're pretty good at this. I don't need to give you big and long explanations. So I get x squared plus 5x minus 24, and that is the answer to the first part. Okay? Yes, Mom?
Why does it say use x to the second plus bx?
Ax squared plus bx plus 6.
That confused me.
Right, exactly. Yes, and that's why I'm not even remotely worried about your grades. Plenty of you, if you got a 0 today, you're going to get 100 tomorrow. What I really wanted this question to bring out was how sometimes the questions seem really weird, and sometimes kids think weird means difficult. Weird does not mean difficult. Weird means think about it, okay? Now, the next one says, what does the next part say?
Has to make sure that your expression of...
That's right. Okay, so and what is the first one? X equals 7?
Yeah.
All right, so to find the area here, the original expression is x plus 8 times x minus 3. So let's plug in a 7. What's 7 plus 8?
15.
And what's 7 minus 3?
4.
4. And what's 15 times 4? 60. Now let's take the expression you came up with. That's why it says your expression. And let's plug in the 7 into this. So what is 7 squared? 49. What's 5 times 7? 35 minus 24. And 49 plus 35 is going to be 84. Minus 24 is 60. So notice they're both the same. So that serves to kind of say to us, hey, I probably got the expression right. It would be highly coincidental if they worked out the same and your expression was wrong. Does that make sense? Okay, so what's the next one? X equals 10. So again, it says x plus 8, so what's 10 plus 8? 18. And what's 10 minus 3? 7. So 18 minus 3, 18 times 7 is 126. Okay, so far so good? Now I'm going to plug into here. X squared plus 5x minus 24. If I plug into 10, what's 10 squared? 100. What's 5 times 10?
50.
And minus 24. So 100 plus 50 is 150, minus 24 is 126. Notice that they work out the same. That's all they wanted you to do. Now that you've seen what they wanted you to do, is it really difficult? Yeah, I don't think it is. So if you have any issues or any problems, you can go over, review the video tonight, or just review the quiz. I think you will be okay with it. I don't think it's particularly difficult. Tomorrow's quiz is the same exact thing. The only thing I do is I think I change it from like x plus 8 times x minus 3 to, I don't know, x plus 5 times x minus 2. That's all I do. Everything else, these questions here, all the bottom in red and green, they all stay the same. Okay? We're good? You see what I mean about tomorrow? Don't you think tomorrow you're going to look at it and go, now that I know what to do, we're in the right direction? One of the things that concerns me on your Common Core Regents exam is I think that they tend to make a couple of questions up that are very hard to follow what they're looking for. So I want to give you some in class and let you struggle with them. I want you to have a little bit of a hard time without me telling you what to do, because am I going to be there on the Regents to whisper in your ear what it is you're supposed to do? No. So, struggle. Struggling's okay, particularly when you get 3 quizzes and you bomb the first one, who cares? And there were, I think, 400 or 500, so it's not like everybody bombed. Okay. Let's see here. Now, let's take this and shrink it down. And let's go to today's Do It. This is lesson 41. Did you say we have 42 today?
Yeah.
Yeah, okay, so let me go to 42. We're kind of jumping around a little bit here. I'm trying to cover things in a little quicker time because of, obviously I'm gonna miss some time when it comes to my knee surgery. So, let's go through, and we talked the other day about the importance of this question. You can only get this question right if you completely understand all of the laws of exponents. So let's go through this step by step. First, I'm going to square 3x cubed, which means I'm going to square everything. So that's going to give me 9x to the 6th. Then I'm going to square 2x, and that's going to give me 4x squared. So far, so good? You can actually do it in the opposite order. I'm just kind of used to the second one having an exponent and the first one not. Over 6x to the 5th. Now, if I multiply out the top, I'm going to multiply coefficients, which is 36, x to the 8th over 6, x to the 5th. Any questions? Okay. What's 36 divided by 6? 6. X to the 3rd. How many people got that right? All right, we're looking at 3, 5. We're looking at 2/3 to 3/4 of the class. We really want to get to the point where when you look at a question like that, you go like, piece of cake. I got this. This is very easy to do. All right, next one. Find 4 consecutive odd integers such that the sum of twice the first, the second, and twice the fourth is 29. Now, this is significantly more challenging than you did the other day. But let's work our way through it because I want you to see that it's really not that hard. So the other day when we were working on word problems for the first time, I said, look, word problems have one of two things to do. They're either about a shape or they're not. Okay? Is this about a shape? No. So what do we always set up if it's not about a shape?
A table.
A table, good. So this is about consecutive odd integers. So I have first consecutive odd integer, second consecutive odd integer, third consecutive odd integer, fourth consecutive odd integer. So here's my table. And what is that first odd integer going to be?
X.
X. Now, what is the next odd integer, Lily?
X plus 1.
No. And I'll explain why in just a second. X plus 2. Lily, what's your favorite odd integer?
3.
What's the next odd integer after 3?
2.
No.
Oh, wait.
Next odd integer after 3. Is 4 odd? No, 4 is even. So it's 5. What did you have to do to go from 3 to 5?
Add 2.
That's right, and that's why I'm adding 2 here. Okay? If it says consecutive integer, it's x, x plus 1, x plus 2, x plus 3, and so on. If it says either, this is big, guys, either consecutive odd or consecutive even, it's always 2's. So x, x plus 2, what's next? X plus 4, and then x plus 6. Okay, so I did 4 consecutive odd integers. That's all done. So I can cross that off. Such that the sum of twice the first. Well, there's the first. It's in the table. It's right there. What's twice the first? How would I write twice the first? Come on, this isn't hard. 2x, good. Okay, so there's the twice the first part. The second, what's the second one? What does it say? Right there, read it. X plus 2. You actually gave the answer, Andre. So there's the second one. Yes, you did. And twice the fourth. How do I say twice the fourth?
4x.
No. 2 times, and then write the fourth one, x plus 6. So there's my twice the fourth. So I did the first one. Here's the first one. See it? Everybody looking?
Yeah.
There's the first one. What's this one?
2.
The second one. What's this one? This is the fourth one, and then I want twice the fourth. So this is the sum adding of the first, twice the first, the second, and twice the fourth. Now, when I add that up, I got to get 29. I can cross that up. Now I've used everything, it's time to solve. 2x plus x plus 2 plus, distribute, 2x plus 12 equals 29. Same side, same operation. 2, 3, 5x plus 14 equals 29 minus the 14. This is the easy part. 5x is 15. Dividing by 5, x is 3. Am I all done? No. Why am I not all done? Billy?
Because it says you have to find 4.
That's right. So the first one's 3. What's next? 5. Next? 7. Next? 9. There are my 4 consecutive odd integers. Okay? Any questions? Now, we significantly upped the game when it came to this question. So my advice to you is that if you are still struggling with it a little, before you start tonight's homework, just take a couple of minutes to redo the question. Go back over it. As you go over a question or two like this, and you'll be getting plenty in your homework, I think you'll find that you grow comfortable with these setups. What helps so much is that table in the beginning. The table really allows you to focus on, oh, x is the first one, x plus 2 is the second one, x plus 4 the third one, and x plus 6 the fourth one. Yes?
If it said like even integers or just like regular integers, would it be x plus 1, x plus 2, x plus 3?
Regular integers. Even and odd are both like this.
Okay.
And the reason even and odd are both like this is because you have to skip one. If you start with your favorite even integer, say 8, isn't the next even integer 10? So you had to skip the 9, so you had to add 2. If I start with an odd one like 7, the next one's 9. I had to skip the 8. So when I go by odds and by evens, I always end up skipping one. So that's why you go up by 2, 4, 6, 8, and so on. But if I do regular integers, do you skip anything?
No.
No, so that's why it's 1, 2, 3, 4, 5. Plus 1. Okay, any questions? All right. Now, today, we start talking about ratio problems. And if you understand what a ratio is, it's a very easy transition to these ratio problems. I would say that these questions are far easier than the one we just did on the do it. Okay, now, it says here that you have what kind of shape? Triangle. What do I do every time I have a problem about shapes?
You draw the shape.
Draw the shape. Good. So I'm going to do that. Here's my shape. Nice looking triangle right there. That's like, I have future Picasso skills. Okay? Now, they're in the ratio of 1 to 2 to 3. And this is what you got to wrap your head around about ratios. Ratios, if things have a common ratio, that means they share something in common. For instance, here are some common ratios. 2 to 3, 4 to 6, 20 to 30, I don't know, 50 to 75. No, 1 to 10 is not common with those. Okay? Because in each case, can't I reduce each of these ratios to 2 to 3? Okay. Now, there's something that each of them has in common. For instance, 2 to 3 is its simplest form. 4 to 6, I have to multiply by 2. 20 to 30, what did I have to multiply by? 10. What about 50 to 75? By 25. In the problem, you don't know what that common thing is. So when there's something you don't know, what do you call it? Come on, it's algebra. What do you call it when you don't know what it is? X. So it says it's in the ratio of 1 to 2 to 3. And this common thing they have, I don't know what it is. So I'm going to go 1x, 2x, 3x. So anytime I have a problem that talks about a common ratio, I call that common ratio x, and I just put it into where it says the ratio. It says 1 to 2 to 3, so I go 1x, 2x, 3x. What do you think I would do if the ratio said 3 to 5? What do you think I would put? 3x and 5x. What if it said 7, 8, 9? 7x, 8x, 9x. Okay. Now, that's my diagram. Now, it's the three angles of a triangle. Does anybody remember anything about the three angles of a triangle? They add up to 180. Very good. So, if I do 1x plus 2x plus 3x, what do I have to get? 180. Now, This is same side situation?
Yes.
So what do I got all together?
6x.
6x equals 180. Dividing by 6, x is 30. Am I done? No. Why am I not done? Everybody. Come on, everybody, why?
Plug it in.
You gotta plug it in. It says it wants the measure of each angle. So the 1x angle would be 1 times 30, which is 30. The 2x angle is 2 times 30, which is 60. And the 3x angle is 3 times 30, which is 90. Now what I like to do with word problems is when I think I have it right, I then go back and do it with arithmetic. Remember, an algebra is an arithmetic with variables. So I just check it out and add them up. What's 30 plus 60?
90.
And what's 90 and 90?
180.
Did they add up to 180?
Yes.
Isn't that what they were supposed to do?
Yes.
Bang, I got it right. Okay, any questions? Good, try the next one. Okay. So, 3 brothers inherit $280,714 from their mommy. The brothers are John, Tom, and Joseph. Joseph is the favorite. He has a Technicolor coat. Does anybody get that?
No.
Anybody in the play?
Yeah.
Who's in the play? One person? 2 people?
There is no play.
No. Have been in the play in the past.
In like the past.
Yeah, in the past. All right, there's a very famous play called Joseph and the Amazing Technicolor Coat. It's been on Broadway. I think the high school's done it a couple of times. It's about a story in Genesis in the Old Testament about this brother named Joseph, and his father made him a really fancy coat. You know what I'm talking about now? Okay, so that's why I call him Joseph, and he's the favorite, because in the story he's the favorite. Now, there's John, Tom, and Joseph is the favorite, and they bequeaths the money in the ratio of 2 to 2 to 3. Of course, Joseph's the 3 because he's the favorite. So it's in a ratio, so 2x plus 3x is 287.14. How many people wrote that on their paper? I hope all of you, right? Okay, good. So this is 7x is equal to 287.14. This is a really easy division. Divide by 7, and I'm going to get $40,102. Now, it doesn't ask a question, though. All right, well, anyway, that's the common ratio number. And then if you want to find this brother, you got to multiply it by 2, so that'd be $80,204. The next brother is $80,204. And the last brother is $120,306.
What?
Yeah, you just multiply by 2,
2.
multiply by 2, multiply by 3. Okay? Any questions? Good, try the next one. By the way, that word bequeath means to give to, as in like an inheritance. End the games, let's go. Come on. you all get X to work out to be 12?
No.
What'd you get?
I got 13.5.
Did
I
you,
did
did you
8x.
pr-
I got 8x.
All right.
I got 48.
You're adding 2 plus 3 plus 4. Guarantee it's not 48.
No. Biggest number, right? You're supposed to put 12.
Oh, no, slow down. I didn't say what's the final answer. I said,
my
what
bad.
did you get for X?
My bad.
Did everybody get 12 for X?
Yes.
Except Andre, who added up to 8. Now, the biggest one is 4 times 12, which is 48. Yeah, you were a step ahead of me there for a second. Any questions? No. Okay. So we're officially all caught up because that was today's thingamajiggy. Now, you have 2 choices. If you are squeamish, I strongly suggest that you start your homework and don't look up. If you are not squeamish, then let us see what you have. Here we go. This is the cartoon version. You go home on your free time and do
Welcome
this.
to virtual knee surgery. This activity will
Yeah.
show you the process of replacing a failing knee joint. Are you ready? Today, our patient is a 76-year-old man.
I'm 51.
It is mandatory to check the patient's vital signs before beginning surgery. An anesthesiologist in the operating room performs this step. If the patient's vital signs are not in the normal ranges, we will not proceed with the surgery. Using the healthy person's vital sign chart as a reference, can our patient undergo surgery today? It looks like surgery will proceed as planned. Take a moment to look at our patient's x-rays. Which knee do you think needs surgery?
Yeah, mine is way worse than that.
You're right. His left knee appears worn down and lacking cartilage, which is likely the cause of his pain. The nurse has begun prepping our patient for surgery by placing an IV needle in his right hand. Now it's your turn. Use the marker and write your initials on the proper knee to be operated on. This may seem silly, but it's an actual step taken to prevent wrong site surgeries.
This is actually a really big deal. A few years ago, this has happened a couple times. Somebody went into the hospital to get like a leg amputated, and they cut off the wrong leg. So then what happens is you still have to get the other one amputated. So now you end up getting them
The
both amputated.
anesthesiologist
So they
administers
actually do
drugs
that.
through the IV and through a mask over the patient's face. What function should these drugs perform?
Stop
Good
you
work.
from moving. Forget the
Great.
surgery, which I can tell you, you forget. You don't know it all.
Fantastic.
Yeah, you
After
get
the
loopy.
patient is unconscious, and before the first incision is made, we need to establish a sterile field around the surgical area. A series of sterile drapes isolates the surgical field from the rest of the patient's body. A tourniquet is applied to cut off blood flow, which allows a clearer view of the surgical field during surgery. To kill the bacteria on the patient's leg, clean it in a betadine solution. This scrubbing process will limit the chance of bacterial infection.
Come on.
Betadine scrub is applied 2 more times, followed by the final arrangement of sterile drapes.
Here comes the fun part.
Why do you think knee surgery involves so many drapes? Good work. Use the sterile marker to draw the location for our incision, and don't forget to mark the perpendicular lines too. Typically, the incision line is 6 to 7 inches long. What purpose do you think the perpendicular lines serve? Outstanding. Now for the incision. Take the scalpel and cut the skin following your markings. Let's use the Bovie pencil to cauterize the veins. This will help decrease blood flow into the surgical
Cauterize, you can read cauterize as burn. That's so
The
they
rake
don't bleed.
retractors fold the skin and tissue out of the way, exposing our patient's knee. To operate, we need the patient's knee elevated and bent so the bones are fully exposed. Now the leg is at the proper angle. Use the rongeur to remove the anterior cruciate
Oh, come on, here
ligament,
comes the fun
or
part.
ACL, the meniscus,
The
and
next
any
couple
bone
of things are
spurs that
fun.
may be lurking about.
Smoothing out the bone a little. Cutting the ACL out.
Are you a good sculptor?
Here we
It's
go.
time to shape the femur,
Here we go.
tibia, and patella so the new knee components fit properly. A hole must be drilled inside the femur to set up the distal femoral cutting jig and alignment device.
Smile, Sarah.
The jig is put into position and helps
Oh,
ensure that the
let's
cuts
have
made
some
to
more
the
fun.
bone are exactly what are needed. Now hammer in the pins to hold the jig. We can now remove
Oh,
the
it gets
alignment
better.
device.
Hold on,
the
wait.
pins will hold the jig firmly in place. Now for some real bone shaping. Use the bone saw to cut the bone so it is prepared for the new femoral component.
It's like,
Another cutting jig, along with the bone
No, but they're
saw,
thinking,
allows
what
us
if it's
to finish
me?
shaping the femur. Let's move on and shape the tibia. The tibial cutting jig is aligned with the big toe and the
So you
highest
do
point of
understand
the
why I'm
tibia.
going to be out for a
This
few
will
days,
ensure
right?
the leg is properly aligned after surgery. Secure the jig.
Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios, amigos.